explain this to me. How can scientists keep arguing about experiments when we're talking about predicting the future?
Right? Like, just when you think the data's solid, someone comes in with a new way to measure presentiment, or a meta-analysis that throws the whole thing into chaos.
We're asking the big question. Can you actually see the future? Or is it just coincidence and a trick of the mind?
This is The Voice That Knew, a skeptic's journey into precognition.
We are digging into the science, the stories, and the absolute weirdness of it all.
We've got 20 episodes to figure this out together. You're not going to want to miss where this ends up.
Welcome, everyone. We're glad you decided to join us.
Let's go.
Okay, so we've spent a lot of time talking about these big, dramatic experiences, like hearing a voice. But what if precognition is quieter, almost physiological?
Exactly. What if your body knew something was coming, even if you didn't? It's a concept called presentiment, and it's where a lot of the modern laboratory research really kicks into high gear.
Presentiment. So, like a sentiment that comes before the event. That's a great term for it.
It is. The idea is that our physiology, our heart rate, our skin conductance, pupil dilation, subtly changes in the seconds before we're exposed to an unpredictable emotional stimulus. It's the body bracing for impact before the rock is even thrown.
Okay, that's a wild claim. Because how would my sweat glands know whether the computer is about to show me a picture of a flower or a picture of a spider?
That is the billion-dollar question. It challenges our fundamental understanding of causality in time, which we've touched on before with block time and retrocausality. But instead of philosophy, researchers tried to nail it down in the lab. They tried to measure the future's echo in the human body.
And this isn't just one or two studies, right? This is a whole field of inquiry.
A whole, very contentious field. We're talking decades of experiments, meta-analyses, and some of the most heated methodological debates in science. It's a battleground for what counts as evidence.
So how do you even begin to design an experiment for something that, according to standard physics, shouldn't exist?
Very, very carefully. And that's where the ingenuity comes in. Parapsychologists have developed three main approaches over the years to try and capture this ghost in the machine.
Okay, what are they?
First, you have those presentiment experiments we just mentioned. They're about measuring the body's unconscious physiological reactions to future random events. Super small scale, personal.
Right, the skin conductance and heart rate stuff.
Then you have the complete opposite approach, macro scale. This is the Global Consciousness Project, which asks if enough human minds are focused on one major event, can we detect a flicker in the background noise of the universe, or at least in a global network of random number generators?
Okay, from the body to the whole planet. That's a jump. And the third?
The third tries to find a middle ground. It's about enhancing a person's potential for psi. This is the Ganzfeld experiment, where you put someone in a state of mild sensory deprivation, like a sensory void, to see if it's easier to receive information you shouldn't have access to.
So, three totally different scales: the unconscious body, the collective global mind, and the isolated individual mind, all trying to get at the same question.
Precisely. And each one comes with its own data, its own successes, and its own, very passionate army of critics.
Okay, let's dive into the first one then. Presentiment. Walk me through a typical experiment. What does it actually look like for the person participating?
You'd sit in a quiet room, hooked up to sensors, measuring things like your skin conductance. You're watching a computer screen, and after a countdown, it's going to show you an image.
And the key is that the image is chosen completely at random after you've already been looking at the blank screen for a few seconds, right?
That's the absolute critical part. The computer's random number generator doesn't decide whether to show you a calm, neutral picture, like a landscape, or a highly emotional one, like a violent or erotic image, until the last possible moment.
So there's no way for the subject, or even the experimenter, to know what's coming.
Correct. And the hypothesis is that in the 2 to 10 seconds before the image appears, your body will show a different physiological response depending on which type of image is about to be chosen.
Your heart races a little more if it's going to be a scary picture. Huh. Okay, so what does the data say? Does this actually happen?
Well, this is where it gets interesting. Researchers like Dean Radin and Dick Bierman reported significant effects, and when you pool the data together, it gets even stronger. A major meta-analysis by Mossbridge and others in 2014 looked at dozens of these studies.
And a meta-analysis just combines the results of many experiments to get a more reliable picture, right?
Exactly. They looked at 37 different studies with over 1,000 subjects. They found a small but statistically significant effect. The effect size, Cohen's d, was about 0.26, and the cumulative odds against it being a chance finding were astronomical, like 6.3 times 10 to the 17th power.
Wait, what? I mean, 0.26 isn't a huge effect, but odds like that, that's not just a statistical blip. So the data, when pooled, seems to suggest there's something there.
According to that meta-analysis, yes. Another way they measured it, using something called a Bayes factor, strongly favored the idea that there was a real effect. But, and this is a huge but, critics have a lot to say about why that effect might be showing up.
Okay, before we get to the critics, let's look at that second approach, the Global Consciousness Project. This sounds like something out of science fiction.
It really does. The idea, which started at Princeton in 1998, was to set up a network of hardware random number generators, RNGs, in up to 70 locations around the world. These devices are essentially electronic coin flippers, spitting out zeros and ones in a sequence that should be completely unpredictable.
Based on quantum tunneling, right? So it's supposed to be truly random.
That's the design, and they just collect data 24/7. The hypothesis is that during major global events, things that capture the simultaneous attention and emotion of millions of people, the output of these RNGs will become slightly less random, a subtle ordering in the chaos.
Like, the collective consciousness of humanity is imposing a tiny bit of structure on a quantum system. That's a massive leap.
It's a colossal leap, but they ran it for years. They pre-registered about 500 global events, natural disasters, terrorist attacks, New Year celebrations, things like that. And after 17 years, they calculated the cumulative result.
And what did they find?
A deviation from chance that they calculated at 7 standard deviations, a 7 sigma result. The odds of that happening by chance are about 1 in a trillion. It's a huge statistical anomaly.
7 sigma? I mean, in physics, 5 sigma is the gold standard for a discovery, like the Higgs boson. So, what happened on September 11th, for example?
That's one of their most cited examples. They reported significant deviations in the network's data, with one calculation showing it started hours before the first plane hit, with a p-value of about 0.028. And the data spike associated with Flight 93, when passengers fought back, was apparently enormous.
Before the plane hit? Okay, that's deeply weird. They're still running this, right? I saw something about a GCP 2.0.
They are. It launched around 2024 or 2025. The goal is to expand the network to thousands of next-gen RNG devices, improve transparency, and maybe even get to a replicable 5 sigma effect. They're even looking at smaller events, like large-scale meditations, which also seem to show significant results.
All right, so we have the body and the globe. What about the third method, the Ganzfeld? You said it was about sensory deprivation.
Yeah, this one has a long and storied history. You bring in a participant, the receiver, they recline in a comfy chair, you put halved ping pong balls over their eyes, shine a red light on them, and have them listen to white noise through headphones.
Ping pong balls. Okay, why?
It creates a uniform, unpatterned visual and auditory field. It's called the Ganzfeld, German for total field. The idea is to reduce the normal sensory input, the noise, so that any signal from psi might be more easily detected.
So you quiet the senses to hear the whisper of telepathy or clairvoyance.
That's the theory. While the receiver is in this state, another person, the sender, is in a separate, shielded room, looking at a randomly selected target, usually a picture or a short video clip. The sender tries to mentally send the image to the receiver.
And afterwards, the receiver is shown 4 options, one of which is the correct target, and has to pick which one best matches the impressions they had.
Exactly. By chance, you'd expect a hit rate of 25%. So the question is, do people consistently score above 25%? For decades, the answer has been a battle of meta-analyses.
I remember hearing about the debates between the skeptic Ray Hyman and parapsychologist Charles Honerton on this back in the 80s.
That was the defining feud, but the debate continues. More recently, a 2024 registered report meta-analysis looked at studies from 1974 all the way to 2020. It found a moderate overall effect size of about 0.08 and confirmed the effect wasn't declining over time.
Huh. So, again, a small but persistent signal that seems to survive meta-analysis, even using modern statistical tests for things like publication bias.
It appears so. The analysis also found that selected participants, like artists or people who meditate, produced much stronger effects. But like with everything else in this field, the numbers don't end the argument, they just start it.
Okay, so let's get into those arguments. Presentiment, GCP, Ganzfeld, they all have these meta-analyses showing small, statistically significant effects. Where do the critics come in?
They come in swinging, and frankly, with some very strong points. Let's start with presentiment. Critics like Eric John Schwarzkopf point to a whole host of potential flaws in the original studies. Things like stimulus imbalance or subtle statistical artifacts that can create a false signal.
What's the biggest criticism, though?
Expectation bias. The argument is that maybe participants aren't feeling the future, they're just unconsciously learning statistical regularities in the trial sequences. If the randomizer isn't perfectly random, or if there are subtle patterns, their bodies might be learning to anticipate, not precognize.
So it's a clever form of classical conditioning, not precognition. And proponents say they've tested for that and it can't explain the effect.
Right, it's a back and forth. But the deeper skeptical argument is one of extraordinary claims. If presentiment is real, it violates so much of what we know about physics and neuroscience that you need evidence that is absolutely bulletproof. And critics argue the evidence just isn't there yet.
Okay, what about the Global Consciousness Project? A 7 sigma result is hard to ignore.
It is, but critics say you can get there with questionable research practices. The main accusations are cherry-picking and post hoc analysis, choosing which events to look at or what time window around the event to analyze after you've already seen the data.
That's a cardinal sin in science. But didn't the GCP say they pre-registered their events in a public registry?
They did, and they claim about a quarter of their formal events are pre-registered and audited. It's their main defense. But skeptics also point to confounding variables. Could environmental noise or electromagnetic fluctuations affect the RNGs? And there's a lack of independent replication.
And I saw one alternate interpretation, that the effect might be real, but it's not global consciousness. It's an experimenter effect. The researcher's own intention is what's influencing the RNGs.
Exactly, which in a way is just as radical a claim, but it shifts the source of the anomaly from billions of people to a handful of researchers. It's a fascinating internal debate.
And the Ganzfeld? What are the holes there?
Oh, the classic critiques are legendary. Ray Hyman's 1985 review of the first wave of experiments was devastating. He found none of them were free from methodological flaws. Inadequate randomization, poor documentation, and the big one, sensory leakage.
Meaning the receiver could have gotten clues through normal senses, hearing a whisper through the wall, the experimenter giving unconscious cues.
Precisely. And even though protocols got much tighter, with computers automating everything, the replication issue persists. You have one meta-analysis in 1999 by Milton and Wiseman finding an effect size near 0, then another by Storm and Ertl finding a significant positive effect, then a Bayesian reanalysis by Rauter and others saying there's no evidence. It's a statistical knife fight.
So this pattern, a small, persistent signal in meta-analyses, met with intense methodological criticism and inconsistent replication, it seems to apply across the board.
It's the central drama of the field, and it's led some proponents to propose a really interesting, if convenient, idea, the psi paradox, or the elusive nature of psi.
Which is what exactly?
The idea that the phenomenon itself is sensitive to observation, that the very act of trying to pin it down in a strict classical scientific setting, where you try to replicate it exactly, might cause the effect to diminish or disappear. They point to the decline effect seen in other areas of science, where an exciting initial finding gets smaller over time.
Huh. So psi is shy? That sounds like a way to immunize a theory against falsification. If it doesn't replicate, you can just say the conditions weren't right or the skepticism killed it.
That is the absolute core of the skeptical counterargument. It makes the claim unfalsifiable. But some researchers are trying to formalize it, like with the model of pragmatic information, which views psi as an entanglement process that is fundamentally destroyed by the kind of certainty that replication demands.
So where does this leave the field? If replication is the cornerstone of science, and your phenomenon seems to resist it, what do?
You double down on rigor. The field is keenly aware of the broader replication crisis in psychology, and they've been adopting all the proposed solutions: pre-registration of studies, using Bayesian statistics, demanding larger sample sizes, and even doing adversarial collaborations, where believers and skeptics design and run an experiment together.
Has that been done? An adversarial collaboration?
They're being promoted. There's even a transparent psi project underway to try and confirm or deny the meta-analytic results with maximum transparency. It's an attempt to move past the endless debates by building a protocol that everyone can agree on beforehand.
So, after digging through all of this, the presentiment studies, the global RNGs, the Ganzfeld, where do we actually stand? Is there any consensus?
Consensus? Absolutely not. What we have are two entrenched positions, both looking at the same messy data set and drawing opposite conclusions.
On one side, you have proponents saying, look, across different methods and decades, these meta-analyses consistently show a small but real effect that defies chance. It hasn't been explained away.
And on the other side, you have skeptics saying, look, the history of this field is littered with methodological flaws, inconsistent replication, and plausible conventional explanations. A small effect in a meta-analysis isn't evidence for a reality-breaking phenomenon. It's evidence of subtle bias and noise.
It really feels like the debate is less about a single definitive experiment and more about one's prior assumptions. What do you find more plausible? That our understanding of causality is wrong? Or that our scientific methods are imperfect and can be fooled?
That's a perfect summary of the situation. There is no single study you can point to that settles it. What you have is a persistent, frustrating, and deeply intriguing anomaly. The signal, if it's there, is vanishingly small and hard to distinguish from the noise of experimental error.
So the real story here isn't necessarily about proving precognition. It's about how science grapples with a phenomenon at the absolute edge of what we can measure and understand.